discussing dynamic typing in Python. Dynamic typing in Python. Okay. So students, dynamic typing in Python. So what does it mean? See, as in C++ or Java, the binding of variables is static. Means the type of variable is known only at compile time. Okay, you do declarations of variable prior to using them. So this happens in C++, in Java. But Python eliminates this necessity of declaring a variable before its use. It says that the variable could be uh, a variable could be assigned to be an object of a specific type only at runtime. Means the type of a variable decided at runtime, and secondly, you need not declare the variable prior to its use in Python. For example, let us say a equals to 1. Okay, so a equals to 1 here means, as in C++, it means that a is a memory location which has value 1. But in Python it means that this 1 is an object, and this object is nothing but a memory location to which this variable a is binding of. Suppose I say a equals to 2. In C or C++, it means reassignment of the same memory location pointed by a to the different value 2. But in Python it means different. In Python it means that there is another memory location. 2 is an object which is referring to a memory location, and the binding of a has changed from a equals to 1 to equals to 2. A has now binding to this new object 2 which has value 2. So this is meaning in Python. So in Python the bindings change, bindings of a variable is changed. Okay, but sometimes we have to pay cost also in using this flexibility of Python. For example, suppose if I say a equals to here at this point 3.14, and later on I say a equals to hello. Now this is referring to different types. In the first two statements a is of type int, but in third statement a is of type float. In the fourth statement it is of type string. So you need to take care of this. What is the type of the variable at a particular instant? Because if you do operations not specific to that particular object type, then it may lead to errors. So you have to take care of the type of the object at different locations for using that variable. Okay, so this is the main point in Python. Now Python also has some shared references. For example, suppose a equals to 2, b equals to a. Now b is referring to the same variable as is b referring to the same variable which is referred by a. Means a has binding to an object of type int which has value 2. B has the same reference to a, means b is also pointing to the same object 2 of type int. Now if you do this, a equals to 1, then the change in a will get a new binding a equals to 1 of type int, but the binding of b will remain same as 2. Why? Because 2 and 1, 2 is an int data type, and int and string are immutable data types. Immutable data types means they cannot change their bindings. So when these are immutable data types, it means that when you reassign this a to be 1 in this statement, then a will bind to a new object of type int having value 1, but b will continue to point to the old object, that is 2. Okay, so this is meaning of shared reference. But if, and secondly, if a is 1 2 3, here it is a list, these are square brackets, the elements are separated by commas, this is a list. Okay, now if you say b equals to a and you change a0 equals to, by through this indexing you change a0 equals to -2, then this change will be reflected both in b and a. Why? Because list is a mutable data type. Mutable data type means it may change. So B has reference to A. So when you try to change the value of one of the index of A through this indexing operation to be -2, means the zeroth element, which is the first element of the list, is changed to -2. This change is reflected in B also, because B is also referring to the same list. And if you want to impact the change in A but not in B, then you need to assign B to a different list. And if you assign B to a different list, then then both will refer to this different objects, different list objects. So that is possible. But in this case, this change will reflect in both ends. Okay. Now let us take one more example. Suppose I assign A equals to 1, 2, 3, say list, and B equals to 2, 3, 4. Now if I change A0 to be -2, then, and if I print A now and print B now, the result will be A will give out 2, 2, 3, and the B will be printed out to be 2, 3, 4. Now both refer to the different list, so the change impacted in A through this indexing operation is made only in the list A, the list pointed to by A, not in B, because B refers to this different list. Okay. Now let us take one more example. Consider this. A is 1, 2, 3, A equals to 1, and A0 equals to -2. Now see, in this example, A is pointing to the list object which has value 1, 2, 3. Now A binding is changed. A now has value 1, which is of integer type. Here it is list type, here it is integer type, and now you are doing indexing operation in A. The binding of A has changed. A is now referring to an integer object, and indexing is not possible in integer. So this will produce an error. Okay. So this is the main. Now the significance of telling this example here is simply that you need to take care of the type of the list, type of a variable at runtime, because this binding can change at runtime. So you will need to take care of this. But if you try to apply an operation to a variable whose binding has changed to a different type, in which that operation is not possible, you produce an error. Okay. And let me also tell you that objects, we are frequently referring this one as object, integer object, 1, 2, 3, enclosed with square brackets, the list object. What is object? Objects are simply the memory locations, and they have some types associated with them. Okay, and sometimes you also need to take care that how many variables refer to an object, means how many referencing variables an object may have, and this is because this is done, means the referencing, how many referencing variables object has. This is done in order to return the memory to a garbage collector in case an object is not being used anymore. So if an object is not being used anymore, it may release its energy, release its memory at any time to the garbage collector, so that it could be used by other objects. Okay. Okay. So now dynamic typing clear to you. Okay. So let me take one more example. Okay. Let us say A equals to 1, B equals to A equals to A minus 1. Let us understand this also. Now here A is 1, B has the same referencing as A. So B refers to the same object 1 of type int. So B is again has become an integer type. Now A has been changed from A minus 1. A minus 1 will give a new binding to A, that is 0. So A will be binding to a new object 0. But the referencing of B will remain same as to be of object 1. Why? Because again int is a immutable data type, and in case of an immutable data type, if you try to change the binding of a referencing variable A, it does not make impact change in the another reference variable B, because int is a immutable data type. So B will continue to point to the previous object, that is 1, even though in the next statement A has been changed from 1 to new binding, that is 0. Okay, got it? Okay, so students, here we finish this topic.